In this last video for Chapter 2, we will be analyzing how to pick those numbers for factoring a polynomial function. So here we discussed the rational root theorem. So let's take a polynomial function 3x to the fourth plus 13x cubed plus 15x squared minus 4. And our goal is we want to factor completely so we can graph it and do everything with it. The question is, where do we pull the numbers from? And it's a real simple procedure. By the rational root theorem, what it says is we take the factors of the last term. So take the factors of this term. So it's plus or minus 1, plus or minus 2, plus or minus 4. We then take the factors of the first term, 3, plus or minus 1, plus or minus 3, and we divide all of them. So in other words, we have all these possible combinations. Plus or minus 1 divided by 1 is 1. 1 divided by 3 is 1/3. Plus or minus 2, plus or minus 2/3. So I'm finding all the different combinations of these numbers. Plus or minus 4, and plus or minus 4/3. This is the list of all possible rational roots. I stress rational. Rational means you can write it as a fraction, not irrational. So there are still possible irrational roots that we cannot solve this way. But this tells you all the rational roots that would come up through factoring. So now let's take that and we have to basically find the factors. So we're going to use synthetic division. So 3, 13, 15, 0, -4. And this process is something you're not going to like. You pick a number. So the idea is you must pick a number and try it. So from this list, I'm purposely going to be wrong on this one. I'm going to pick the number 2. 2 times 3 is 6. Add them to get 19. 2 times 19 is 38. And I'm going to stop there because you can already tell that you're not going to make it. You can add these together to get 53-ish, whatever. And you can see next time you double, you get it 100. There's no way you're going to cancel out and get 0 here. It's like no way. So 2 does not work. So we're going to try another number. Let's try a value of 1. And obviously this can take a while because if you keep getting the wrong answer, you would have to try a lot of different numbers. And there's really no cheating way of doing it. There are a couple of little things that can help you, and through experience you get a little bit better at it. But in reality, it is guess and check. 1 times 3 is 3. 13 plus 3 is 16. 1 times 16 is 16. 31, and again, you can see there's no way this is going to work. We're not going to make it. So 1 does not work. So 2 and 1 do not work. So you pick another number. So let's pick -2. I shouldn't give up so easily here, but in the end I can tell you now nothing happened here that would help us find it. So let's try -2. 3, 13, 15, 0, and -4. 3 times -2 is -6, you get 7, you get -14. Now I see something which I like here, in that it's getting smaller for a second there. So you get 2, you get -4. Is that right? Seems like I just want to make sure I didn't make any stupid mistakes here. That should be a positive one. I had a feeling. It seemed too close to not work. So now we're left with this expression. X plus 2 times 3x cubed plus 7x plus 1, 7x squared plus 1x minus 2. So now we've got to keep going. We found -2. We've got to try this on this now. My tip to you is always try -2 again, because you want to make sure it's not double root. The worst thing that could happen to you is you found -2, and then you don't check the double root, and you're trying all the other numbers, and in the end it was just a double root. So you might as well take it real quick and try it again. Again, you want to use the already factored one. So if we try it again, -2 times 3 is -6, you get 1. -2, you get -1. I think it actually works. And there you go. It's a good thing you tried. So now we know the factors are x plus 2 squared times 3x squared plus x minus 1. I don't need to go any further because I have a quadratic. The goal is always to get a quadratic that you can solve. You notice we have an x to the 4th, so therefore we have to do it twice. If it was x cubed, we only have to do it once. We can try factoring this. What multiplies negative 3 adds to 1? It's not going to work. We're going to have to solve this. These have irrational solutions. Solve it using quadratic formula. Negative 1 plus or minus square root of 13 all over 6. Notice these are irrational numbers. These would not have shown up using the rational root theorem. So therefore, our x-intercepts are x equals negative 2 and negative 1 plus or minus the square root of 13 over 6, where negative 2 is a double root. So let's do one more, just to practice our rational root theorem. The last problem I would like to do is f of x equals, how about 3x cubed plus 8x squared minus 9x plus 2. And so now the first and foremost we need to find the possible roots. State the factor of this number, plus or minus 1, plus or minus 2. Whoops. Divided by the first numbers, plus or minus 1, plus or minus 3. I try not to give you numbers like 24, which are going to leave you with tons of factors. So plus or minus 1, plus or minus 1/3, plus or minus 2, and plus or minus 2/3. First, we have a cube. So if we can just get one factor, we can then factor this using either quadratic formula or through actually just using factoring skills. So let's try to find the first number. Let's try 1. You plug in 1, you get 3, 11, 11, 2, 2, 4. That stinks. I'm going to double check my work to make sure I didn't make a stupid mistake. 1 times 3 is 3, that's 11. 2, 2, that looks good. So let's try negative 1. 3, negative 3, 5, negative 5, negative 14, 14, 16, so that's not even close. Let's try another one. Let's try 1/3. Fractions, using fractional numbers really isn't that bad. Usually things cancel out nicely. 1/3 times 3 is 1, and you get 9. 1/3 times 9 is 3, you get negative 6. And 6 times 1/3 is negative 2. There you go. So we have that. So we have 3x minus 1 times 3x squared plus 9x minus 6 equals 0. So now I've got to factor that. I'm going to pull out a 3. That'll make my life a little bit easier. And I believe we could factor this by hand maybe. What multiplies negative 2 adds to 3? Nope, that doesn't work. The signs are messed up. If that was positive, we could do it. So this is a quadratic formula. Negative 3 plus or minus the square root of 3 squared, which is 9, plus or minus 4 times 1 times negative 2 all over 2. So our roots are x equals 1/3 and negative 3 plus or minus the square root of 17 over 2. So the last thing I would like to do is just write out the rational root theorem. If you let the rational root theorem says the following. If you let p of x equal a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, I'm going to go all the way down to a sub 0, then the possible rational roots are p divided by q where P are the factors of A sub naught and Q are the factors of A sub n. So basically the last is the first. In reality, if you think about this method, it's really very similar to how you factor a trinomial using, last year, just basically using the first and last terms. It's basically the same application. So that wraps things up for Chapter 2 on the rational root theorem. I'll see you tomorrow. Have a good night.